Chapter 6, Section 4, Dilations. A dilation uses a scale factor to enlarge or reduce a figure. Scan the lesson and complete the graphic organizer. So things that are like a dilation might be scale models or microscopic images, things like that. Characteristics, a dilated figure is the same shape, but it's a different size. I'm sure there's some other characteristics in there that we can think of. Things I've already learned I can use for this. Well, multiplication comes in handy. Graphing, that comes in handy. And again, I'm sure there's other things that I'm not thinking of right away. Dilations in the coordinate plane. A dilation with a scale factor of k will be an enlargement or an image larger than the original if k is greater than 1. It'll be a reduction or an image smaller than the original if k is greater than 0 but less than 1. It'll be the same as the original figure if k is equal to 1. So the scale factor is k. When the center of dilation in the coordinate plane is the origin, each coordinate of the pre-image is multiplied by a scale factor k to find the coordinates of the image. So if the scale factor was 2, then we would multiply the x coordinate by 2 and the y coordinate by 2. The pre-image and the image are the same shape, but not necessarily the same size, since the figure is enlarged or reduced by a scale factor. In example 1, it says a triangle has vertices at these coordinates. Find the coordinates of the triangle after a dilation with a scale factor of 4. So all they did was multiply each coordinate by 4. 4 times 8, 4 times 0 gave us the new coordinate. In point C, 3, negative 2, we did 4 times 3 and 4 times negative 2 to get our new coordinate of 12, negative 8. So the coordinates after dilation are listed here. So they were able to find the new coordinates without any graphing at all. Let's try example 1. It says a triangle has vertices D at 1, 2, E at 0, 4, and F at 1, negative 1. Find the coordinates of the triangle after a dilation with a scale factor of 3. Okay, so let's kind of like mimic this setup here. So if we have D, that's 1, 2, that's going to become well, we'll just do it here. So D, this would then become, I know. So let's do a new column for each point. So we'll do E is at, or going across, we'll do 1 multiplied by 4 and 2 multiplied by 4. And that's going to give us our new point, which is D prime at 4, 8. Because 1 multiplied by 4 is 4 and 2 multiplied by 4 is 8. So for point E at 0, 4, we can do 0 multiplied by 4 and then 4 multiplied by 4. When we do that, we get E prime, which is located at 0, 16. And point F at 1, negative 1 can be dilated. 1 multiplied by 4, negative 1 multiplied by 4. So the new points for F prime are 4, negative 4. So the coordinates after the dilation are D, and f prime. Go ahead and try got it A, and then resume this video when you're done. I'm going to do got it A the same way I did example 1. I'm going to put the original coordinate, so W is at -2, 4, and then I'm going to put the operation. So this is a scale factor of 2. So I'm going to do -2 times 2. I'm going to do 4 times 2. So my W prime coordinates are -4 and 8. For X, my coordinates were 1, 4. So I'm going to do 1 multiplied by 2 and 4 multiplied by 2 to get my X prime coordinates, which are going to be 2 and 8. Y was -3, -1. So I'm going to do -3 multiplied by 2 and -1 multiplied by 2 to get my Y prime coordinates of -6, -2. Finally, Z is located at 3, -1. So I'm going to do 3 multiplied by 2, and then I'm going to do -1 multiplied by 2 to get my Z prime coordinates at 6, -2. And then we will copy here. So the coordinates after the dilation are hopefully you got the same answer as I did. Let's look at example 2. It says a figure has vertices J, K, and L. Graph the figure and the image of the figure after a dilation with a scale factor of 1/2. So they plotted J, K, L, and then they multiplied the coordinates by 1/2 to get the coordinates of the image, and then they plotted the image. To check their answer, they drew lines throughout the origin and each of the vertices of the original figure. The vertices of the dilation should lie on those same lines, which they do. So we're going to try that here in example 2. It says a figure has vertices. Let's plot these vertices. H is at -8, +4. J is at 6, +4. K is at 6, -4. And L is at -8, -4. Graph the figure and the image of the figure after a dilation with a scale factor of 3/4. Okay. So it wants us to find the coordinates of the image with a dilation, a dilated image with a scale factor of 3/4. So let's start with H. H was -8, 4. So we want to do -8 multiplied by 3/4. We can do that. So multiplied by 3/4 is -6. Let's do, let's see, is it shift to enter? 4 multiplied by 3/4 is 3. So my new point at H prime is going to be at -6, 3. For J, the original point was at 6, 4. So I'm going to do 6 multiplied by 3/4. I'm going to do 4 multiplied by 3/4. My new point, J prime, which is located at 4.5 and 3. K, located at 6, -4. So I'm going to do 6 multiplied by 3/4. I'm going to do -4 multiplied by 3/4. My new point, K prime, is located at 4.5, -3. And then finally L, which was located at -8, -4. We can do -8 multiplied by 3/4, and we can do -4 multiplied by 3/4. So our new points for L prime are -6, -3. And so if I plot my new points, H prime is at -6, +3. J prime is at 4.5, +3. K prime is at 4.5, -3. And L prime is at -6, -3. I'm going to connect these points together to finish creating my image. And then it talked about earlier that to check our answer for a dilation about the origin, we can run lines through the origin and through our points, and if it goes through the points of our pre-image and our image, then our dilation is correct. So let's do that. We should be able to run a line from the origin through these points, and it should touch both points. It does there. It does there. I should want this side over here. It goes through there. And finally, It goes through both of these points as well. So our dilation is correct. The last thing I can do is label my points. So this would be H, J, K, L, and then we have H prime, J prime, K prime, and L prime. Hopefully that makes sense. Go ahead and try got it B, and then resume this video when you're done. Got it B says a figure has vertices. Let me get my marker at -1, 1. That's point F. 1, 1. That's G. 2, -1. And -1, -1. Graph the figure and the image of the figure after a dilation with a scale factor of 3. Okay, I can do that. So let's connect these lines first. And then we have a scale factor of 3. So before I do my scale factor, I'm going to label these points. So I have point F, G, H, and I. Can't really see that I there, but that's okay. So, and then we need to create a dilation with a scale factor of 3. So if point F is looking at -1, 1, well then I want to do -1 times 3, and I want to do 1 times 3. Not sure why that's not. 1 multiplied by 3 is 3. Okay. So then our new point for F prime is going to be at -3, +3. For G, which was at 1, 1, we could do 1 multiplied by 3, and then 1 multiplied by 3 to get our new point for G prime, which is going to be located at 3, 3. H, which was located at 2, -1, can be multiplied. So 2 multiplied by 3 is 6. -1 multiplied by 3 is -3. So our H prime coordinates are 6, -3. Finally, for I, which was at -1, -1, we could do -1 multiplied by 3 and -1 multiplied by 3. So our I prime coordinates are -3, -3. And if I go plot these points, let's see, F prime, -3, +3, 3, 3, 6, -3, and -3, 3. Let's connect our image together with lines. So here's our image. We can label these points as F prime, G prime, H prime, and I prime. And then just like before, if we run a line through the origin, it should go through the points of both the pre-image as well as the image as sort of a check to make sure that we got this correct. So there's one line. It does work. Here's another line. Let me pull this one in. That one works as well. Let's do another line. These points, that one works. So then this one should work as well. And it does. So as I zoom out here, you can see the pre-image, the image, and the line that goes from the origin through all the points that are necessary. Let's look at example 3. It says, through a microscope, the image of a grain of sand with a 0.25 millimeter diameter appears to have a diameter of 11.25 millimeters. What is the scale factor of the dilation? So write a ratio comparing the diameters of the two images. So the diameter in the dilation over the diameter in the original is equal to 11.25 over 0.25, which is equal to 45. So the scale factor of the dilation is 45. Let's do the same thing here in example 3. It says the pupil of Josh's eye is 6 millimeters in diameter. His doctors use medicine to dilate his pupils so that they are 9 millimeters in diameter. What is the scale factor of the dilation? So we're going to do the same thing. We're going to do the diameter in dilation. So diameter in dilation over diameter in original. Dilation. So in the dilation, they were 9 millimeters, and in the original, they were 6. So that's 1.5. So the scale factor of the dilation is 1.5. Go ahead and try got it C, and then resume this video when you're done. Got it C says Lucas wants to enlarge a 3x5 inch photo to a 7.5 by 12.5 inch photo. What is the scale factor of the dilation? So let's do diameter in dilation over diameter in original. Or this time we can just do length in dilation over length in original. So we'll do both. We'll do, so the 3, so in the dilation, the 3 was 7.5. So 7.5 over 3 is 2.5 times. In the dilation, the 5-inch side was 12.5. So 12.5 over 5 is also 2.5. So the scale factor of the dilation is 2.5.